Okay. So last week, when we gave an overview of the module in terms of what we'll cover and say what the coursework and assessment would be like. And then this week, we're starting with the first lecture, which are covering and the visual data analysis. So again, this will be an introduction, nothing too in-depth yet. Okay, and so first, very quickly, and in terms of the textbook, I'm going to using this one, Visualization Analysis and Design. So it's written by a professor in Canada. She's like a leading figure in the field. And so this book, I mean, there's not that many good textbooks on data visualization, and this is one of the better ones I came across. And so the book is available in the library as e-copy. And again, if you go to the module page and then click on the, okay. So if you go to the module page, okay, sorry, the text might be very small. I'm just logging in. And then go to the reading list. And then should be this one. And it will tell you it's available online. Someone already get a physical copy. And that's how you get the books. So that's the way the university wants everyone to use an online version now. So we'll use that quite a bit. Oops. Oh, there's something wrong with the PowerPoint slides. Let me just restart again. Okay, and then today, in terms of actual lecture, we're going to cover two parts. The first part and discuss what is visualization, and then second part we can talk about data types, and which is very important because to design an effective visualization, you have to have the method specifically for the type of data, and for example, if it's numbers or it's categorical or it's other type of data. Okay, so we start with the first one. I guess most people would have a kind of understanding of what visualization is without a precise definition. And so this is a definition given in the book. And so we probably will just use it now. Again, so this is, you don't really need to say remember or and what the definition is, just to understand some subtleties in there, mostly for understanding. And so according to the book, and visualization is computer-based visualization systems provide visual representations of dataset designed to help people carry out tasks more effectively. Okay, and there are many kind of small bits we want to dig into a little bit further, and obviously most people would see this kind of in charts already, and they are probably the most common examples of visualization. And there's more, I mean, less common or more complex ones. And for example, this one, so that's like a 3D scan of people's head. And that's also an visualization. And there's things like this, and which is less common but say more complex visualization to represent data in a specific different way. We'll have a look of that later on. Okay, and the first part, in terms of visualization, and has human involved, and so it is not the type of method which you run some code or software and it will give you an answer at the end, and it always have a human involved in the analysis process. So certain type of tasks you can easily done with only computer. For example, if you want to do any statistical calculation from simple ones, the mean, the average, the standard deviation, to more complex ones. And you just need to give it data and you can have some code and run it completely. You don't really need human involvement in the process. But for the other ones, we still need human involved. And sometimes, and because maybe the application problem is not very well defined. It's not like as simple as say, I want to calculate the mean. So we already kind of had this, and in our first lab exercise, if you were there. And so the task is to find something interesting from the data set. So this is not something you can write a code to do it for you, and still have to be human involved to come up with ideas of what can be potentially interesting, and then to test whether that is the case or not. Okay, and so actually, and that's exactly the problem, say sometimes, and the question is, and so the challenge is, don't know what is the right question to ask. And if you know the right question to ask, then it's kind of halfway there already. Okay, and so the link is not working, and don't know why. Okay, and the other reason we want to have a human involved, and is we want to use human brain and as another computational resource. And so if we speak in terms of computers, so human brain is actually a very powerful computer, much more powerful than any, say, physical computer human has built so far in terms of computation power. But also we as human are only only good at certain things. And for example, if you just want to say remember something, or you just want to do some complex numerical calculations, then the human brain is not very good. But we are very good at detecting visual patterns. If we see something, and there's certain patterns that we're very sensitive to, we can detect easily. And partly because, for example, that's because the result of the evolution or survival purpose. For example, we can detect things moving and very easily, because that's very important for our survival. And so the goal is then to use this additional human computing power, and to couple it with what computer can do, the physical computer, PC, can do, and to get the best results for the analysis. Okay, and so in a sense, and the visualization is there's a need to support or augment human capabilities rather than replace human completely. So this is certain situations where if you just let human do all the work manually, that might be too difficult. And then you can use visualization to support. Okay. And then, so as an example of a fully automated decision-making system or data analysis system, and you could have an AI, to be the judge, so to decide and whether a person is guilty or not, and not using human, but using an algorithm or code. And the question is, do you really want that? Can I do a quick poll just to see how do I add the poll here? Here. Hey, give me 1 minute. I'm just creating the poll. Okay, and it should be there. Polls. Okay. Okay, and you should see a poll now on your computer screen. And so if you just pick yes or no, and I give you a few seconds. Okay, yeah, I think quite a few people find it now. Ah, okay. Uh, 10 more seconds and then we'll close. I think now we have, oh, 20 people answered. Yeah, okay. So you can see now, and this is the results of the polling. So we had 20 people and voted, and roughly 1/3 and said yes, and 2/3 said no. Okay, and it actually will be very interesting to understand why you said yes or no. And but for now, so that's actually the general. I think that's a good representation of what the general consensus is. And I think the majority of the population don't prefer an AI judge. And even there is kind of certain studies which actually showed, and in many cases, actually, the algorithm would make better decisions than human. But there's a concern because the human would have, say, a mood or even just potential and more bias and into the decision. But the reason mostly against using an AI judge is actually, in many cases, it's not possible to justify or understand why the AI made certain decisions. So there is a chance it makes a wrong decision, but there's no way to tell why that is the case. And so as a result, I think currently, for example, the GDPR law or the EU law and does not allow to use a fully automated AI system to make such decisions. Okay, and also the other part of in terms of, and you want a human in the kind of a data analysis process, but obviously you want a computer as well. And as I said before, computers are good at certain things. And for example, they can remember things very well and can do computation very fast. But there's also other things, and it's important to have a computer involved. And for example, if you want to do this kind of 3D visualization, it's almost impossible to create this kind of visualization manually or just by human. So you definitely need computer to support. And then the other examples is this kind of visualization, which is interactive. That means the user can interact with the visualization and which will change, depends on the user interaction. Again, so this is something you cannot not really do manually on a piece of paper, and you must need a computer to do this. If it's, let me see if it's still working. Yeah. And so this is one of the more quite common and online. Let me move this Zoom thing out of the way. And online visualization. So this is to visualize the data of different, they call it the great wars or the big wars in history. And I'm not sure if you can see, it's from 1914 to 2014. So not every single war in the human history. And as you grow, okay, and you scroll down, you can see now that's the first interaction. So that it responds to the users scrolling in the browser, and they give you a little bit of information of how the visualization works. So it says these are the poppy flowers, and it's the size represents the number of people died in the war. And you can see the stem start from here and can tilt towards the right. And so the start point representing the time when the war started, and how much to the right represents how long it lasts. For example, here is when it ends. So for this is, I think, the First World War, and they started in 1914 and ended at 1918. And the size of the flower indicates how many people died in the process. Okay, and so, and now keep scrolling down a bit more. Yeah, and this is give you a little bit of background, saying why do we use poppy, and that's the flower used to remember the people who died in the war, especially the soldiers. And then you can click explore, which I can show the actual visualization, which is similar to what we saw. Okay, and then you can easily see, and this is all the main major wars happened from 1914, I think it was, and all the way to 2014. And then you can mouse over each of these to see more details. Say this is a war starting before the 1900s and lasts a very long time. So that's the Dervish state versus Ethiopia. And so that's, and you can click, and which give you even more details about that particular war. It says that's when it starts or ends, probably very small on your end. And duration, how many people died, where it's died, which country is involved, etc., etc. Okay, and obviously, and these are the two biggest ones, and the World War One, and this is the other one, and World War Two. So these are the two wars with the most casualties in history. And you can, I mean, the link is actually in the slides. You could explore more yourself later on. So for example, this is kind of one of the more recent one with lots of fatalities. So for example, this is the Vietnam War, lasts for 10 years and has more than 2 million people died. Okay, and so back to the point. So that's also the reason why you need a computer involved, because you need to provide this interaction which can respond to user actions, and which is only possible when you do it on the computer screen. You can't do it on the paper manually, or at least it will be very difficult. Okay, and the other point, just looking for my mouse, and in terms of visualization, and it is a visual representation. And in other words, it's represent data visually. And so the reason we do this is it's replace something called cognition, which is how we think, with perception, is how we see things. And relatively speaking, we are much better at perception, seeing and processing the visual information than thinking. So I'll give you a quick example here. And so we have this information. Just imagine this is the data you were given. It says A is connects to B, and B connects to C and D, and C connects to E, and then D also connects to E. Okay. And then the question is, and what is the shortest distance between A and E? Let's say the distance is, if A go to B is 1 and B go to C is 2. Okay, and do we have any answers? If anyone can think of something, you can type in the chat. What is the shortest distance? Because there's multiple paths. You can go from A to E. Does anyone have any answers at all? Not yet. Okay, and so this is kind of presenting the information, and you have to solve it. You use your cognition. So your mind have to think, okay, first A connect to B, B connect to C and D, and C can goes to E, D and can also goes to E. Okay, and but also optionally, say a data visualization way would be just plot something like this, and you can easily see the shortest between the A and E will be 3. You can also either go this way or you go in other way. So I would argue, say, if we present the data this way, it's much faster for us to find answers compared to this way. And because, and we are much better at, say, processing this information visually rather than, say, try to imagine this in our own mind. Okay, and the next one is and depend on vision. So obviously, and data visualization is mostly designed for vision, and it's actually possible to design for other sense as well. It can say design for hearing or even for smell, but they are less effective. And so one of the reason, and we use a visual visual sense or the vision is because we have a much higher bandwidth connected to the brain, in the sense visually we can process information much faster compared to other senses. And so if you use kind of like a megapixel sense, so if you treated the eyes almost like a camera, and so it's almost like equivalent of 576 megapixel cameras. So that's probably higher resolutions than any existing digital cameras we can have. But also, the way we process this visual information is again also very fast. And so that means you can have up to 576 million data points at every single moment and visually. And we involved to process both in parallel and pre-attentively. Pre-attentively means something so pre-attentively means something we can process or get information without actually go through the thinking. And so this is the example. And so we can all see the red T within all the other T's very quickly. And so this is one of the pre-attentive pattern. So we as human can spot this odd one very quickly without having to go through everything. Okay, and so in comparison, it's potential to represent data using sound. And there's actually people using that to represent data. And the issue is that the bandwidth was much lower. So the amount of information you can represent at a single time is very limited. You can potentially using the pitch and volume of a sound, but that only means you can represent 2 data points at a single time. And the other problem is, the same sound would have different semantics and for different people, just as the same piece of music, some people may like it, some people don't. And some people would imagine the music is describing one thing, and other people could imagine or understanding it as describing completely different things. So that makes it difficult to understand the sound, what it actually represents. Okay, and also the other potential disadvantage of using sound is that it's quite difficult to provide an overview. So you cannot. So there may be a lot of data, and if you convert that into sound, there will be a music or sound sequence lasts for say 30 minutes, and it's quite difficult to remember what happened at the very beginning when you come to the end. So you don't really have an overview ability. Also, you can use touch, or they call it haptics, to represent information. And so we all have this on our phone. When we have a message or have an incoming call, and the phone will vibrate. So essentially use a vibration as a way to tell you, okay, there is a coming call, essentially representing like 1 bit of information, either true or false. So when it's vibrating, that means it's true, there is an incoming call, and with no vibration, there is. But then what can you potentially represent, again, is very limited. And you can potentially using, say, the amount of vibration, how strong it vibrates, or maybe the frequency of the vibrations to represent some information. Again, that's very, very limited. Only 2 information you can represent at the same time. Then it has the same issues as the sound. People might perceive them differently, and also it's difficult to get an overview. Okay. And finally, the other senses, you can potentially use taste or smell and to represent information. And work on this is still very early stage. And one of the main obstacles is saying there's no good way we can reliably record and replay devices. For example, if you want to represent certain data using smell, then you must be able to record the data, which is a smell, and play back later on, which is exactly the same smell. And currently we just don't really have that, say, the physical device that can do this. Whereas, for example, for sound or vision, that's quite easy. we can accurately record the sound or video and then play back later. But we just don't even have that for the taste and smell. So make them not suitable or practical yet to record information or data. Okay, and so idioms and design space. So these are the two kind of concepts we're going to come across a lot. And so the idiom is like an approach to creating and manipulating visual and representations. And so it's called idiom, and it's not a rule in the sense, so these are not 100% correct all the time. So maybe another word for idiom will be maybe like guidelines. So these are the general rules people would usually follow when you design visualization, but it is not and hard and fast rules because there could be exceptions to these. And so in this module, we're going to come across a lot of idioms, depends on, say, if you have this type of data and this type of analysis task, what will be a good visual design? And obviously for every specific data and analysis questions, the visual design could vary. But there's some guidelines to help you to provide you to at least a good starting point, and then you can further refine them. And the other concept is the design space. So the design space really, it just means all the design options or all the possible visualization you can have. And for example, again, and using the lab we had last week, the data set we have, which is a table, contains the data about different cars. And then there are many different ways you can visualize the data. And first, it depends on what data you visualize, and then depends on what kind of pre-processing do you do on the data. Do you calculate something and visualize? And finally, in terms of visualization itself, and you can choose among different charts. And for each type of charts, you can decide what to put on, say, the XY axis, what the color represents, etc., etc. So, and the total combination of possible visual design and is almost infinite, practically speaking. And so really the task of a human or for someone to design a visualization is to, out of this very big design, possible design space, and to find the one that's most effective for the particular task and the data type. So which is exactly what this idiom can help you with. The idiom can provide you guidelines, say for a specific task and specific type of data. This is usually a good type of design, instead of we have to search the entire space every time. Okay, and then this is the other word, which is called visual encoding. And so essentially, it just means how do you map from the data to a visual element. And so, for example, I want to map the price of the car to the x-axis. That's one way of doing visual encoding. Or you can map the price of the car to the, say, the size of a circle in your scatter plot. That's a different way. So there are many different ways. And the idiom is usually about a visual encoding, and it will tell you what are good ones and what are the generally not so good ones. Okay, as I said before, there are many possibilities on how to create visual encoding. First, you need to decide which one data attributes to encode, and then how it would be represented. Would that be the x-axis, or maybe color, or maybe size? There's many different ways. Okay, and these are some examples. And you can map to the positions, you can map to the lens and grayscale, color, how curved the lines are, how tilted the lines are, and the area or the size of the circle, or sorry, a square, or maybe the volume of a cube. There are many different ways. These are just some examples. You can create other ways to represent the value as well. Okay, and then there's also an idioms, like a general guidelines about interaction. And so we see an example early on in terms of visualization, which is not static. People would interact with the visualization and or change to show more information or change the view. And there's some guidelines on how to design these as well. And again, so there's even more possibilities. That means, and what will be the initial view look like, and what the user interaction would be, and once the interaction happens, how the view, what will be the updated view. And each of these has many different possibilities. Okay, and so this is like the important concept. And so the first one is idiom. So it's like a guideline, and to give you some initial starting point of how to design the visualization, and the design space, and is always a possible design. And visual encoding just means how do you map data to the visual representation, and which is called visual encoding. Okay, and then the next thing, again, is still from the definition, is to focus on the effectiveness. Okay, so the effectiveness will be depends on the task. And so one visualization which is very good for one task can be quite bad or much less effective for a different task. For example, some tasks you just want to get overview of the entire data set, and the other cases you want to look at the details about the specific things. Then you probably would have completely different visualizations for these. Okay, and the other thing I probably will talk about more later on as well is in terms of the visualization. The goal is not to make something that looks beautiful or fancy. That's not the goal. And sometimes it's the simpler visualization actually that's easier for the user to complete the task. And they are not necessarily not the most beautiful looking visualizations, but if they are more effective, say people can complete the task faster or more accurate, then it is a better visualization. So that's the only measurement. And say how beautiful the visualization is could potentially be a secondary criteria, and how fancy the visualization is usually is not a criteria. And actually, usually the fancier the visualization, the less effective it is, because, for example, people might not be able to understand exactly how the visualization works, which will take them longer to understand or cause them making more mistakes. Okay, so I give you examples in terms of the effectiveness. Okay, and so I guess, and this is something everybody would know before, and it's pie chart. And so you can represent several numbers in a pie. And so I guess we can all see, and so for these pie charts, each of the slices, which are these ones, are all roughly the same size. But and so if that is a task, just to decide whether the slices are all roughly the same size, then this is fine, it's completely working fine. But say if you have a different task, is to say which slice has the largest portion. So for example, for this first circle or the first pie, even the different color slice are almost the same, but one of them will be slightly bigger than the others. Yeah. So again, let's just do a quick poll just to see which one do you think is the biggest one. To stop this. Okay. Oops. Let me change this to a different poll. Yeah. And can you see the poll now?
Yes.
Yeah, so you should be able to see. So just let's look at the first slide, this one, first circle. So you should have options. Just pick the one you think has the largest portion. Is that black and the red? I call this and beige one. This is yellow and this is beige two. So these two are very close in color. So just vote. Which one do you think has the largest portion? Okay, I'll give you a little bit more time. Currently we have 14. And 10 more seconds, and then we'll close the poll. Currently we have 17. Okay, I think that's probably and all we're gonna get. Okay, yeah, so you should be able to see the results now on your screen. So you can see we have about 70% people say the black part is the largest one, and just 12% says the red. Beige one has 6%. No one picked yellow, and then beige 2, there's 12%. Okay. So, but if we look at exact the same data, and the other two circles will be quite similar, but just different way. If we look at like this, oops. Okay. There's something wrong with the PowerPoint slides. Okay, if we look at exactly the same data, just different representation. So in this case, using a bar chart. So this shows the first one, and this shows the second one, and this shows the last one. And if we look at this one, I think everybody can see very easily the black part has the largest value. I doubt everybody would pick any other part. So whereas if we look at this result, we can roughly say about 30% of people actually make the mistake. And I imagine it will take longer time for people to using this pie chart and compared to people looking at this one. For this one, people probably will be able to pick the largest one straight away. Okay, and so this is to say, just depends on the task, and the certain visualizations will be much more effective compared to the others. So in this case, if we want to find the slice which has the largest portion, and then the bar chart representation is much more effective than the pie chart, even maybe say for me, this is very obvious because I know this for a long time, but initially you might not be so aware or sensitive to this fact, but something you need to be quite careful with. And because say, if this one can allow people to complete the task almost at 100%, and this one, from what we just saw, and is only about accuracy of about 70%. So that's a big difference in terms of how effective the performance of people using these different visualizations. Okay. Okay, and then so just link back to the concept we mentioned before. And so these are the two different design solutions. So, or two options from the entire possible design spaces. And you can represent these numbers, the 5 different numbers, in many other ways as well, just 2 of them. And in terms of visual encoding, this one map the number, however that is, into the angle, so basically the angle of these slices in the pie. And next one is map the number to the height, essentially how tall these bars are. Okay, so this is the visual encoding, mapping the number to some visual elements. And then these are 2 different ones, and they are of quite different effectiveness. And okay, so the next one is in terms of the limitations that we have in terms of doing data visual analysis. And so there's 3 different limitations. And the first one is computational limits. And so when you need to process very, very large data, and the amount of, say, how fast the computer can run and how much data it can host memory will becomes issue. And I think this is quite common. So if you have a not so powerful computer, and you need to load, say, just in Python, a very big data file, 7 GB, and everything might slow down just because, and the computer cannot process it properly or fast enough. And the same thing here for visualization. So if you want to visualize millions or even billions data points, and then it might take a long time for the visualization to be generated by the computer, and that becomes a limitation. So usually it's about how fast the CPU takes to process this and how much memory it can hold data. Okay, and then the second limit comes with display. And so that limits how many different items you can show at the same time. So usually this is directly correlated to the number of pixels you have. And in most cases, and the more pixel you have, oops, what? Sorry, and it happened again. I think this has something to do with the Zoom recording, which is a bit unfortunate. Okay, it's back to the second, and limitations is about display. And so usually the more display you have, and the more information you can show on the screen at the same time. And so let's say you have, I don't know, say close to 1 million pixels on your screen. So a pixel is like the smallest dot you can display on a a screen. So in theory, the maximum number of data items you can display on such a screen is 1 million, because you can use each pixel to represent Y items, and you can't really represent any more because you can't use 1 pixel to represent 2 data points. And it's not to say, and this is a good way to represent. It just says in theory that becomes the limit, and say if you have more than 1 million data points, you just couldn't possibly to show everything at the same time, and that becomes the limitation. And so related to this is a concept called information density, and it just says for the within a fixed space, how much information you display or how much data you display. So you have a 1 unit area, and if you display 10 points, which would have less information density compared to you display 100 data points within the same area. So I think that's fairly intuitive. Okay, and then the last one is the human limits. And so you can process all the data or show all the data on the screen, but it doesn't means the human can understand it. So if you overwhelm the human, say the cognitive capabilities, how much we can see and make sense, then it actually has a negative impact on how we can do the visual data analysis. Okay, and so I'm going to show you this example here, and it shows a large and complex network. It has many nodes. So obviously, the number of data points there, or the nodes here, is kind of over how much we can understand. Or in the sense, if we look at this validation, and the only thing we can really say, okay, this is a big network with lots of nodes and lots of connections. That's all we can say. We can't really say too much about the details of the network at all. And you can imagine there's a case even worse than this, and if you have even more data points there. So in these cases, it's kind of over the human understanding limit. So then in the sense, we cannot really make much sense out of visualization at all. So this is usually the most constrained one. And so I think the guideline is, and we can reasonably make sense if you have a few hundred of data points. Again, it varies, and maybe up to 1,000 maximum. That's kind of limit. And anything beyond that, we just don't really have the ability to look at each of them individually and maybe just get an overview like in this case. Yeah. Okay, and so these are the different okay, so these are kind of overview of visualization. So a few kind of important aspects of visualization, say what it is, and why do we need the human, why do we need the computers, and what are the idioms and different design options space, and also say what it are, how do we measure whether it's good or not good, and different limitations we can have about visualization. Okay, and then next part, we're going to move on to the data types. And I already mentioned this a few times. Say, to design a good visualization, a big part is to make sure the visualization fit with the type of data you have. So obviously, if you have location data, you probably want to plot them on the map. You don't want to use, say, a scatter plot or bar chart to show the locations, which usually probably not going to make much sense. And so then before we talk about, say, how do you represent this, which is the visual encoding, we're going to look at different types of data. Okay, so this part can be a little bit confusing, but that's quite normal. And we're going to come back to this and later as well. And after a few times, we will be able to get kind of better understanding of these concepts. And the first is a data type. And you can have an attribute. If you think of these and spreadsheet, attributes are usually the columns. For example, each row is a product, like in the supermarket, and then each column, say the first column can be the product name, the second column would be, say, the price, and the third column will be the weight, etc., etc. And then each of these columns is an attribute. Okay, and then the other one, similar to or the opposite of the attribute, is called items. And just think of the rows and in the column. And so the product one, which including all these attributes, is one item. Say that's the milk, that's the egg, that's the bread, beer. So each of these ones and are the items. So it could be a people if you have a list of, say, the age, gender, address, etc. Or a product. Okay, and then you have the link, and which is a relationship between the items, and so that only happens in the networks. So in the networks, you have these nodes, which essentially are the items, and then you also have these connections between different nodes, which are the link, which does not really exist in, say, in the spreadsheet, but would exist in only exist in network. And finally, a grid. No, not finally. And we have grid, and which is something for 3D modeling, and which we're not gonna really discuss here. And finally, position. So the position just the location data, and you can have a position on a 2D map, or you can have a 3D position, for example, in the space. Okay, and so yeah, the position is usually associated with the map. Okay, and again, so each of these points on a map and is an item, and similar to the points in the link. So we have attributes and items, which mostly apply to this table type of thing. And link is unique to network, and position is unique to map. And the grid is here, and is for sampling of continuous data, which is more relevant in computer graphics. And we just included here for completeness, but we will not really discuss them more. Okay, and then we have the next set is called data set types. And so each data set is a collection of data items or a collection of data. And data set can have types as well. So we can have table, which have the rows or columns, or in the terminology we just introduced before, it's made of attributes and items. And table does not have to be only two-dimensional. You can have more high-dimensional table as well. We'll talk about that later on. And the second type, data set type, is networks, so which is made of node and link. And so the node are the items, and similar to the items here, and the link, as we said, is a different data type. And a specialized case of network is called trees. That means if you have no cycle in the network, that becomes a tree. So you can see here you have a cycle. For example, this is triangle forms a cycle, but here there's no such thing. You can't find a cycle. And fields is specific to the grid. So that's usual to modeling something continuous. Again, we will not cover too much here. We'll not actually discuss this at all. This probably will be the last time you're seeing this. And finally, we have geometry. Geometry essentially just a different name for map, and that's very specific for location or position data type. Okay, and this is the last set of types. Okay, and so that's the attribute type. So as we seen before, an attribute is one of the data types. Okay, but for attributes itself, you still have further subtypes, and you can have the so-called categorical attribute type, and then ordered. And for ordered, you can further divide it into ordinal and quantitative. Okay, we're going to explain each of those in a bit more details. Okay, so we're going to start with categorical. And so an attribute is categorical if it does not have implicit or inherent ordering. Okay, so for example, and this is you can treat this as a, and how to say, treat this as a data attribute, and then no, oh, it happened again. And so we can treat and this as as one of the attributes, which is the shape. And you have this cross and circle, square, or triangle. And there's no implicit or inherent ordering between these shapes. You cannot say cross is before circle and circle is before or after square. You can manually, you can arbitrarily define, but there's no natural ordering of this. And similarly for names, and you can have different orders to order names, but for just two different names, there's no particular order. And sometimes this is have say hierarchical structure as well, and has this different structure, which we don't have to. Okay, so categorical is really good at distinguishing between two things, whether they are the same or different. That's all it does. So you can say, okay, both are apples, or one is apple, the other one is oranges. That's what the categorical is for. And for example, you can have different categories of products in the supermarket. These are drinks, those are snacks, those are chocolates. There's no order between them. They just say they are different categories. That's all. Okay, and you can potentially impose ordering. For example, you can say, I want to sort all the names alphabetically. That's completely fine. And less common ordering might be, I might order the names by the length. So we start with the shortest length to the longest. That's also possible. But again, that's not the natural ordering of the data. Okay, and so that's the categorical data. And opposite to data is called ordered. Then you have ordinal and quantitative. So if we talk about ordered, which it has an order, that's what it's called, ordered, but you cannot do, for the ordinal ones, you can't do the computation, numerical computation. And so the examples is the close size. And if you go by close, you would have small, medium, large, or maybe extra large or extra small, etc., etc. And these have a natural order. And so you can either order them from smallest to largest, or the other way, or vice versa. And it does have a natural order. But what it can't do, and you cannot do any computation. So you can't say I have small minus medium, which will give me some other sizes. It does not make much sense. Or you have small times medium. Again, it doesn't give you any meaningful sense, meaningful sizes. Okay, and then this is the last one, is quantitative. And again, it has a natural order, but also it can apply and computation. So this is probably the most common one, usually just numbers. So for the numbers, you have natural order from small to large. Then you can do different, all kinds of computations, from the addition, minor addition, deduction, to the more complex ones, any complex calculations. And so this is called quantitative ones. Okay, and that's all we want to talk about in terms of data types. Okay, and so a quick summary. So first, about the first part, what is data visualization? So the most important thing is visualization is to support or augment human capabilities and not replace human with entirely computational methods. And we use external representation, so we present data visually, so we can see the data, which will make it much easier to detect patterns in the data, rather than say just we thinking about it in our mind. And then human visual system. Okay, so the reason we use visualization, not using, say, sound or smell or touch, is because the vision system has much higher bandwidth, and then we can processing data much faster. Okay, and then the next thing is very important. For a good visualization is one that is effective, but it's only always in the context for a specific data and a specific task. So the first thing is, and the most important thing to measure how good a visualization is effective, not say how complex or how fancy or how colorful or how beautiful the visualization is. You say how effective it is to answer the questions users need to answer. So sometimes it could be the most simple and plain visualization, but so long as the user can answer to finish the task correctly and in short time, and that's a good one. And then depends on the task and the data set. So there's no one visualization that's good for all data and all tasks. So for different data and tasks, you have different visual designs that's most effective for them. So that's what the design space comes in, and where the idioms are, which are the guidelines to help you to find the ones. And finally, it's the resource limitations. And so it's limitations of what we can visualize. And this can be limited by the computational resource in terms of how much data it can process and hold, by the display, and limited by the display depends on how many data points can be shown on display, and finally limited by our human cognitive capabilities, is how many data points we can still making sense of without being overwhelmed. So usually the human limitation is the most restrictive ones. So we can only see a few hundred, maybe up to 1,000 data points. And anything more than that will become too many. And also that limit is usually way beyond what the display or the computer can process. They usually can process a much larger number than that. So again, this module is really just try to say how we design the visualization to make sure it still fit within our limitations, human cognitive limitations, and by not overwhelming it. Okay, and so this is a picture of in terms of different types we talk about. And so it can be a bit confusing. So we first talk about data types. We had items, attributes, which is mostly for table, and the links, uniquely for network. Position is for fields. And finally, position is for map. And then finally, the grids. Grids is for the fields. So you can more or less ignore the grids part. And then based on data types, you have the data set types, which are the table, contains attributes and items, and you have the network, contains the link and nodes. So link and items, nodes, which is essentially the items. We can ignore this. And for geometry, and we have the items, again, items, and then grids. So we will have, for all these different types, we will have items. And then for the table, we have the attributes. For the network, we have additional links. And for the map or geometry, we'll have the grids. Yeah, hope that make it a little bit easier. And then for the particularly just the attributes here, and you can further divide it into categorical and ordered. And for the categorical, that means these are the attributes which does not have an order. So example would be shape, or would be name, or something. And for the ordered, and just as the name said, these are the attributes which has a natural order, and it can be ordinal like this, which basically means you can have an order, but you cannot do computation. And you cannot say I have a small size and plus a medium size. It does not really give you a larger size. But finally is the quantitative. So these are usually numbers. So you can not only have order, but also you can do various computations. So actually the quantitative one is probably the most common one we're going to come across in the later. So these are different numbers, and the categorical will be the second most common one. And you have different types of name. And this is probably the least common ones. Okay, and in terms of the reading, so at the very beginning, I mentioned that this textbook, whether we be cover 4, used for this part, and this is for reading 1. Chapter 1 and chapter 2 is what we covered this week, and so that will be the reading for this week. Okay, and so that covers the more kind of theoretical part, but we are not quite finished yet. So we still have a little bit of time. So I'm going to cover a bit more using Tableau. Let me start. Okay, and so Tableau is the software we're going to be using for the first coursework. It's, as I mentioned before, and it's a it's a software allows you to create quite complex and interactive visualizations without writing any code. And so it's quite popular and used by lots of companies as well. And so that's the recommended reading for the Tableau. And Tableau actually can be a little bit complex when you first start it, but it actually follows the same kind of concept we talked about, like the attributes and items, etc., etc. And so this book can be useful, and we're actually learning using Tableau. And that is also on the reading list. Oh, I just closed the page. So if you go to the module reading list, apologies if it's too small. and you can see that's this book here. And again, I think it's available online. Okay, so let's start with, and this is a screenshot and from the Tableau version 2019.3. So, and the first number shows which year that was released, and within each year they have a few different versions. So this is 2019.3 version, and I believe so far they made some more changes, but it doesn't really, the interface doesn't really change that much. So this is what you'll see when you first go into Tableau. It's called the starting page, and the things on the left column, it allows you to use a different data, connecting to different data. I'm going to go through that in a second, but this is the button. So later on, you can always go back to this page and by clicking this button. And then talking about collecting data, and you can connect to Tableau server, which is different software, which is server you can get data from. And we're probably not going to be using that. And you can connect to different types of files. You can connect to Excel, text file, which is usually the CSV file, JSON, PDF, and more. And you can also connect to different type of servers. And this can be database like MySQL or Oracle, and it could be also an online database like Amazon Redshift after. And if you click more, there's many more. And finally, you will have some saved data examples. And so these are some of the files that comes with Tableau, and depends on the version, and they change this a little bit every year as well. We're going to see a bit more about this Superstore dataset later on. Okay, and so this is the previously Tableau workbook you opened. Okay, so workbook is a term, just essentially each Tableau file is called a Tableau workbook, and which can contain multiple visualizations. So it's a single one. And if you have opened several ones before, and it's going to show up here. So this is like the recent files from your usual, say, Microsoft Word or other software. And obviously, if you have a specific file, you can just choose here to open the workbook. Okay, and these are some of the samples comes with Tableau, just as you have these sample data set. These are these are the preloaded visualizations which comes with the software. And so here it's just data, for example, a spreadsheet or a CSV file, and these are actual visualizations. Okay, and then there's some useful information here as well. And these are the training data provided by Tableau. And for example, the first one is getting started the video. We're actually going to look at in the lab, in one of the labs. And there's other tutorials and the videos here, which you can look at for. Okay, and some other resources, for example, the other software Tableau provides, they have a blog and forum. And then finally, they have this one here, in the bottom right corner. I think Tableau runs a kind of like a competition every week, and they will pick a validation that people created in Tableau, which I think is really good, and they will show as the viz of the week, which actually change every week. Okay, I'll just give you a quick look of what mine look like. So I'm just open up Tableau now on my computer. Okay, yeah. So the other thing you need to be aware, so Tableau actually is a quite big software. It requires a lot of resources to run. Okay, again, apologies, the text is quite small, but it's quite similar. On the left-hand side, you have these all different data you can connect to. And if you look at more, and you can see there's many other things it can connect to. And from Amazon, from Dropbox, and from Google Cloud, etc., etc. or even OneDrive. Yeah, there's many different things you can connect to. And here I have a bit more. These are the previous validations I opened, and the sample, and this side is very similar to what we saw in the slides. Okay, and yeah, so this is like the main interface of the Tableau, and it has lots of things, so can be a little bit overwhelming. Okay, and so what we're gonna mainly look at, if I can find my mouse cursor, oops, where's my mouse? Okay, okay, it's back now. So you have this menu bar, sorry, this menu with all different functions. Most menus, functions you will be able to find it there, which it has a lot actually. Again, I sweep to see if I just open any of these. Oops. So it's can't find. Okay, anyway. And in the Mac is slightly different. The menu is here. And so you can see different things you can do with the menu. Again, apologies, it's probably very small, the text. And then you have this one, which is the icon or the toolbar, which you have some of these most common tool functions you can use. Again, you can find these from menu. Okay, on this side, which is a little bit different, say the menu and the toolbar is very similar to many other softwares. This is the data you have. And so once you load, and it will automatically try to recognize the different attributes you have in your data. Okay, and just 1 second. It's blocked. And just 1 second. And okay, I'm back. I'm sorry, the screen went black again, so I need to stop and restart. That's gonna be a problem. And okay, and so we're talking about this side, and so this is actually the most important part. It's about the data you loaded, and Tableau will try to understand what are the attributes, what type of data is, and what attributes it has. So this is similar to the data types and attribute types we talked about in the lecture. So it will put all those what we call categorical. What exactly is it? I forgot the term now. So basically those ones you cannot order here. And they have a different name. They call them dimensions. For example, and the city, which is the name of the city, you can't really, it does not have a natural order, and it will be all put in under dimensions. And for the quantitative ones or the ordinal ones, it's all put down here. So usually these are the numbers. And you can actually see the data type. And for example, this says customer segment, if you can read, and you have this little letter says ABC just before it, which says is recognized this is a text type. In other words, you have these say hashtag, and it means it recognizes this as number. You can change these as well. And if something which you think it should be dimensions instead of measures, so it should be a categorical attributes instead of numerical attributes. You can change that later in the visualization as well. Okay, and then this is the actual visualization that you created. Here you show the picture of a scatter plot, which most of you have seen before. And these are the things which decides the visual encoding we said before. So how do you map these different data attributes to the visual attributes in the visualization? And so, for example, these one says columns and rows, and that means the X and Y axis. Yeah, the columns is, I think, the X axis. You can see it says shipping cost. So these show the shipping cost, and the rows are the Y axis, are these ones here, which is the profit, which is these ones. So, and each point here is a product. No, it's actually a category. And then for each category, it has these shipping costs and plotted against the profits. Okay, so these are what the columns and rows for. And these ones controls the other part of the visual mapping. And so this is mapped to the X and Y, which is always important. And here, it allows you to say and control, for example, what is the mark? So how do you represent each data point? Do you represent as a circle, a point? Here is different shapes. And what the color represents. And you can see currently the color maps to the category, and then say what the size represents, what the label represents. And all you need to do is just drag drop, say the category to the color, then the color will be used to represent and the category of the particular product. And you can drop and drag and drop, say price onto size, then the size will represent the price of each product, and so on and so forth. For example, you can put product name and drop it on the label, and then each point, some of the points will show labels, which show the product name. Obviously, you cannot show product name here because that will just too many overlapping and will make it much harder to see. And you can actually see here as a legend. So currently the category maps to the color. So you have category here, and you can see the blue one represents furniture, the orange one represents an office supply, and the green one is technology. So these are the straight category of the product. And the shape of these points actually represents order priority, and it tells you what these different ones means, which actually, and usually I don't think that's a very good way to represent, because the priority has a natural order. So there's a critical, high, medium, and low. But the shape itself does not have a natural order, not like, say, size or color. So those will be better ones to represent. But yeah, these are the things we'll discuss later. Okay, yeah, we kind of look at this now, so we can have a worksheet. We kind of covered these already. And so if we look at my example here, this is the dashboard. Okay, apologies, and you probably will not be able to see the data, the text there, just too small. Yeah, and we're probably running out of time to explain these anyway. Yeah, and so this slide is talking about the left part, which is about these are the categorical values, these are the quantitative ones, and talk about different type, which we already talked about. The dimensions are the categorical, and the measures are the numerical data sets. Yeah, and you can do some calculation as well. So you can do sum, average, etc., etc. And actually, in this particular example here, you can see it might be difficult to see. Let's say it says profit, but also have a sum in front of it. That means the total profit for a certain product. Okay, and then you can create different type of visualizations, which we probably don't have time to cover today in the lecture, but we will certainly do that in the lab next week. Yeah, we're gonna skip those for now. Okay, and so that covers the chapter 1 of the book I mentioned early. And if you don't have time to read it, we're going to cover them in the lab next week as well. And this week's lab, we're going to just continue the discussion we started last week. Okay, and I think that's it for today.